Hey everyone, it's Justin again. There's a short activity in your PDF to focus on before starting this video. You can think of it like a warm-up, where you'll be doing something similar to what Mia is doing here. If you haven't done this activity yet, pause the video now and complete it. Now that you know what we'll be going over in this video, be sure to pay close attention so you can figure out the answers to your questions. Here's that activity you were just working on. Let's focus in on the two problems you were analyzing. We can see that this lesson focuses on writing solutions three different ways: as an inequality, on a number line, and using interval notation. We're familiar with inequalities from the previous lesson, and I even see a little reminder that we can write the inequalities another way by switching the two sides and flipping the sign. Since we've already learned how to write and interpret inequalities, the focus of our lesson today is these other two methods for representing the solutions we get. We're going to compare and contrast the examples we have here to better understand these other two ways to write solutions, starting with graphing on a number line. Let's compare these. First off, you can start by drawing a number line. I like to include 0 no matter what because it helps give people a chance to get their groundings. Then I write the number showing in the inequality in an appropriate location on the same number line. You probably noticed that there is a circle that isn't filled in at the number 4. We call this an open circle. And at the number 7, there is a filled in circle, which we call a closed circle. Now, what's the reason for putting an open circle versus a closed one? Well, an open circle means that the number is not included in the solution. Our inequality here says that x is greater than 4, not greater than or equal to. So 4 is not a part of this solution. Now let's compare that to this closed circle. The closed circle is here because the 7 is part of the solution. This inequality says that x is less than or equal to 7, meaning 7 is included in the solution. Hopefully that answered one or more of your questions if you were wondering about those circles. Or maybe you were wondering about what these arrows represent, or why they're going in these directions. Well, that's what we're going to talk about next. Remember from our previous lesson how x being greater than 4 means that every single number bigger than 4 is a solution? Well, numbers greater than 4 show up to the right of 4 on a number line. This is why the arrow goes to the right, since it represents all of those solutions. And for x is less than or equal to 7, solutions will include numbers smaller than 7. And since numbers smaller than 7 are to the left of 7 on a number line, the arrow goes to the left and represents all of those solutions. Remember, an arrow goes on forever in math, so even negative 5,000 or negative 27,000 are all solutions here. To recap, when using a graph on a number line to represent solutions, the things you'll want to pay close attention to include what number to draw the circle above, whether to fill in the circle or not, and which direction the arrow should point. We're going to learn one more way to represent the solutions to an inequality in this lesson, and that is interval notation. I like to relate interval notation closely to what's showing on the number line. I think of it as reading the arrow we drew on the number line from left to right. Going from left to right, this arrow starts with an open circle, which means the number is not included in the solution. To show something is not included in interval notation, we use a parenthesis. Then, we write the boundary number that is on the left of the arrow. This is followed by a comma, and the number that is the farthest to the right, which This arrow is telling us that there isn't a number to the right that this will stop at. When this happens, we could just say this goes to infinity. The infinity symbol is like drawing a sideways 8. It's not really a number, but more of a concept of going on forever. Since it's not a number that can be included in a solution, or even thought of as a distinct stopping point, we always use a parenthesis with infinity. Now let's compare that to how you would write this solution in interval notation. The arrow on the left tells us the solution doesn't include a specific number that it stops at, thus the parentheses here. Instead, it keeps going on and on forever and forever in the negative direction. To show that our solutions are all the numbers in this direction, we again use the infinity symbol, but the difference between this example and the previous one is that we have to use negative infinity, since these solutions are going in the negative direction. Then we write a comma and figure out our upper boundary, which in this case is 7. Now, if you were like me, you were probably initially wondering what this symbol next to the 7 means. This is called a bracket, and it looks just like a parenthesis, but with corners and straight lines. Once I learned what the parentheses mean, I had a pretty good hint. Did you figure it out? Why do you think we use a bracket next to the 7 rather than a parenthesis? Yeah, 7 is a specific stopping point that is included in the solution. The only time we get to use a bracket is when there is a closed circle on the number line, and the inequality itself contains the equal to part. We could see in the previous example that we didn't have any of these things relating to a bracket. So let's go back to those questions you initially wrote down. You were likely already answering them in your head as I was explaining things to you, but can you take those thoughts and turn them into concrete statements, like what Mia's doing here? You may have even had some super creative questions that I didn't answer in this video, but maybe I gave you enough hints to answer them yourself. If not, it could be a great opportunity to practice your research skills and find the answer on your own. Take some time to go back and answer your questions now. All right. Now that we've completed the activity before the lesson and the guided notes, it's time to make sure you're prepared for the practice game. There's a matching activity to complete in your PDF. Pay close attention to the small details in this activity to make sure that you don't make mistakes. Then be sure to check your work before starting the practice game. See you next time!